I hope you can see my screen right now.
Yeah.
Okay, thank you. So Secfense is a security broker. We like to call ourselves as a security broker. We put ourselves in your infrastructure. It doesn't matter if it lives in a data center or in a cloud. It's something that you own. Once we put it there, it's completely yours. And in order to upgrade any application that you own with multi-factor authentication based on Secfense, you don't need to change the code of the application. You don't even have to know where the users are coming from. So we go like beyond the initial identity, and there's no vendor lock. So everything is in between this layer that is in between the users and the applications. So I'll just maybe show you instead of talking. I like to use for demo. I like to use the application that the viewers would be sure that I do not control its source code. So we like to choose applications like Amazon, eBay, or some big players on the market. Sometimes this example might be confusing, but because we in enterprise customers, we usually target internal applications like CRMs or other applications where users, like internal employees or contractors or partners or their users use. But Amazon is a consumer-facing product, but I like to use this as an example to showcase that we don't touch the Amazon's code, but still we can create this protective layer for Amazon under certain circumstances. So let's imagine Amazon is our application, is an application that you control. At least you have it in your data center or in your cloud, and you control the network traffic to it. So either by controlling the DNS or by controlling the load balancing layer. And there are 3 steps that needs to be taken in order to make this work. So just one more thing, our starting point for any application is the users that authenticate with login and password. So most of the applications in an average enterprise, even though there's a single sign-on strategy in place, in most cases there's a still login and password procedure. And the customer that we've talked to with the record number of applications had 2,000 applications, and only 300 of them were part of the single sign-on strategy, while the rest were just password based. So 3 steps. In the first step, we introduce this application to Secfense. So we create some sort of representation. So I'll do the Amazon. I will create a domain name for it. So Secfense will know what to do with the traffic when it reaches it. So right now, Secfense will know what to do if the traffic that is addressed to Amazon will reach it. In the second step, we need to make Secfense part of the conversation. So we need to network operators usually either change the DNS entry, so the original domain would point to Secfense cluster, or they change the load balancer configuration. Again, it's a very straightforward change comparing to traditional software development integration. In my case, I have a little helper that would force my machine to involve Secfense when I will try to reach Amazon. So if I go back, if I go back to Amazon, let's refresh. So my DNS seems to be cached by the browser. Okay, now the traffic flows through Secfense, but Secfense is completely blind right now. It doesn't. It's like a black box that is transferring the traffic back and forth. Nothing has changed for the users. Nothing has changed for the application. It doesn't even know there's a man in the middle in this traffic. And but now we need to figure out how this application is actually built when it comes to authentication. And we don't touch the application's code. We don't integrate in this traditional form, but we need to learn how it is constructed. So what I've just done was I've enabled the learning mode, and it forced Secfense to like open its eyes. And you can tell that even so, we're not only looking at the traffic, but we also can interfere with the with the traffic, with the actual content that is being presented to the users. But we still don't know how the application is built. So in order to probe that application, in order to scan it, we send a specific username, which is not known to Amazon, but we use it as a probe. And once we send that request, there's a bunch of information gathered from Secfense, both from the network layer as well as from the application side, from the front end of the application. And if we go back to Secfense and we'll hit refresh, it turns out that Secfense has found something. We only present a part of the URI, but underneath it has analyzed the entire payload again for the network and for the DOM. So if I apply what I've just learned, there's already a protective layer for Amazon, like protective layer, protective 2FA layer for Amazon. And I haven't mentioned that Secfense is method agnostic, so we can use any second factor method available on the market. We are not a 2FA vendor, although we come with two methods pre-built, like FIDO 2 standard and TOTP, like Google Authenticator kind of one-time passwords. And so with this layer in place, if I get back to Amazon and I will try to log in with the same user that used to log in with password only, this time Secfense Secfense kicks in. So we are not being redirected to any external gateway. Secfense blends with the application in a way that it can provide security features on behalf of this application. So in this case, Secfense has recognized that this is the intention of authentication, and it knows what kind of user there is trying to log in. And based on the policy that we have set here, the policy is soft, which means that new user would be encouraged to enroll with second factor, but we can mix and match those. I will go with FIDO because this is that's the way that Google that's the method that Google chose and for their employees. So it's the ceremony of authentication is very straightforward. I have a security key in my USB port, and just I will just tap the key, and that was it. So a security key has been just associated with my account. And by the way, I have not pre-populated that user. It was automatically populated when the key was associated. So it was I don't know how much time it took, but it was a complete deployment of an application plus the first enrollment of the user. So if the user will log out, and I'll clean the session so it will not wait 10 minutes, which is the default. Oh, my firewall is shouting. Sorry, guys. And this time it will. So he recognize this is the same user that already has registered his security key, and now I'm authenticating. The ceremony of authentication is the same as the registration with FIDO, and we're good to go. So obviously, if you guys were trying to reach Amazon from your network, this protective layer would not be in place. But I mentioned that Amazon might be a bit confusing. But if this was actually the application that the enterprise controls, this protective layer could be enforced on the entire application, and it wouldn't matter where the traffic comes from. But I just wanted to show you that it's that quick to introduce the second factor. We might be doing this with another methods like TOTP. You can mix and match those methods. If the customer is already using like RSA tokens or other method, it's a straightforward process to like wrap the method, put it on the platform, and then enable it to any application without like integration one by one. And so that's the core functionality. I don't know. I probably have exceeded 10 minutes, but
just a little.
Thom, how are we with time? I have one little thing I would like to show, but if it will completely mess your schedule, I might skip it and probably have it, postpone it to some.
Absolutely. It's probably a good opportunity to move to the panel. It'll give us 20 minutes or so.
Okay, so I'll stop sharing right now, and
fantastic. So actually, while